In this next part of our course, we're going to look at the connection between integration and finding areas under curves and between curves. You'll see this is being able to take your skill of integration and apply it in a practical situation. So you've already seen previously in your integration topic that if you've got limits on your integral, you can calculate a value for that integral. So what I'd like to show you, so for example, if you're working out the integral from 0 to 2 of the function 4 minus x squared dx, you'd integrate, so you get your 4x minus a third x cubed, you put your limits on, and then you do sub in your 2, your upper limit, minus the lower limit subbed in, and that would give you the answer of 5 and a third. If we look at that graphically, what does that mean that we've actually just worked out? Well, what we've worked out is if we drew the graph of y equals 4 minus x squared, right, this is a parabola that has roots at 2 and minus 2, and if we're looking between the values of 0 and 2, then the integral that we just worked out is represented by this area between the curve and the x-axis. So in general, when you are working out an integral with limits on it in this way, you integrate the function and you will get a value for that. That value will be representative of the area enclosed by the graph and the x-axis. So in your notes, we'll have a look at the first example. So our first example is this one here. So if we're having to calculate the shaded area that we're looking at here, so we can see the equation of the function is y equals x squared minus 4x. So we will integrate working out. So we're going to integrate between 4 and 5, and we will be integrating the function which is x squared minus 4x with respect to x, and normal procedure is integrating rules, increase the power by 1, divide by the new power, same with your x, so that would become 4x squared over 2, putting on your limits. And before you would sub in to that, you would simplify that expression. So we're going to have x cubed over 3 minus, that becomes 2x squared, and we'll still get our limits of 4 and 5. So when we sub in, we're going to have 5 cubed over 3 minus 2 times your 5 squared. Now remember, when you're putting in your lower limit, you want to be subtracting, you need to subtract the whole thing, so we need brackets around here. So we're doing subtract 4 cubed over 3 minus 2 times your 4 squared. And then if it's a non-calculator paper, you have to work out each bit individually. If it's calculator paper, then you can use a calculator to do the fraction calculation. At this point here, when you integrate, you get your mark for integrating, you then get your mark for substituting, and after that, really the final answer is really only worth 1 mark. So if it is a calculator paper, make sure you check all your calculations carefully. So multiplying out this bracket, that will give us 4 cubed would be 64 thirds. You'd have minus times the minus at the end here. So you've got 2 times 4 squared being 16, so that's going to be plus 32. If you tidy that all up or collect it all together, we end up with the answer of 2 and a third. And of course, we know that this represents an area, so we can now see the shaded area is equal to 2 1/3, and we can put in units, and then remember area is all about squared, so you should really write squared units or units squared in that particular way. So that's the first thing. You want to be making a connection between your area and recognising that when you're doing an integral with limits on it, you are working out the area under the curve, between the curve and the x-axis. So that's another interpretation for a definite integral. However, there is a wee bit of a complication. So this next bit is looking at what happens when you've got an area below the x-axis. So care needs to be taken if part of or all of the area lies below the x-axis, because what happens here, so if you were integrating, same function as we've just worked with, but integrating between the values of x equals 1 and 4, you end up with a negative value when you do that integral. And as we know, measurement can't be negative, so we'd have to say that the area is therefore the positive version of this, so 9 square units. So key thing, right, with this is to be aware that if you are working out a definite integral and you get a negative in this way, then it's likely that it may be indicating that your area is below the x-axis. So what happens though is, if you're considering a wider spread of values that might look, in this particular case, if you were to integrate between 1 and 5, you would end up still with a negative, but you've got a bit of the graph above and a bit below, so the value is affected by the fact that this bit down below does have a negative value, the bit above has the positive, and they sort of cancel each other out. So clearly 6 2/3 is not the right answer here, so this causes an issue. So what we have to do, and it's quite important to spot this, to find the true area, you need to find two different integrals. So you would integrate for between 1 and 4, which was the bit below the x-axis, and then separately integrate 4 and 5, and then find your total by adding together the two areas that you get. So that would be your procedure that you do that. So that you'll only be aware of that if you have a diagram there, or if you were having to sketch a diagram in order to do that. So this question here, you've clearly got, you're asked to find the shaded area, and it's clearly split up into two parts that you're looking at. So you've got one part above the x-axis and then one part down below. So you're working for this, you would want to integrate. So even if you kind of numbered them or whatever, but you're going to integrate first of all from -3 to 1, and the function is 3 minus 2x minus x squared with respect to x. So when we integrate that, remember a number on its own, you bring back the letter, so we get 3x, you get minus 2x squared over 2, and you get minus x cubed over 3, and you're integrating between -3 and 1. So simplifying that a wee bit, tidying this bit, so we get 3x minus 1x squared minus, you have x cubed over 3, or you can write that as a third. So you've got 1 and then minus 3. So filling in your upper limit there, you're going to have 3 times 1 minus 1 squared minus 1 cubed over 3, and then remember you're subtracting all of this, so you're going to have 3 times minus 3, and you've got minus, and then you've got minus 3 squared, and then you will have minus 3 cubed all over 3. So this bit out with the brackets, you've got 3 minus 1 minus a third, and then within your brackets you've got minus, this first bit comes to 3 times negative 3 is negative 9. Your next bit, you've got negative 3 squared, which is positive 9, so you've got another minus 9. And then this bit here, you're going to have minus 3 cubed, that is negative 27, divided by 3 is negative 9. So you'd have minus 9, which is the same as plus. So putting all of that together, you will end up, you will have 3 minus 1 minus a third, and this bit in the brackets, just you would have plus 9. And your final answer, if you tidy all of that up, is 10 and 2/3, and therefore your area, or your shaded area of the first bit, so is 10 and 2/3 units squared. Right, but remember that's only one part of it. So now what we need to do is do kind of like part 2. I mean, even if you were to, if you have the diagram drawn, you could talk about area 1, area 2. Right, so for area 1, right, that's what we're doing. We're now going to look at kind of area part 2. So don't be writing area equals here, because we're going to end up with a negative value. So we're doing the same thing. We've got 1 to 2 this time. You're integrating 3 minus 2x minus x squared with respect to x. You can jump to the part where you've got the simplified integral, because you've already done this. So you've got 3x minus x squared minus x cubed over 3. And you're putting your limits on there of 1 and 2. So you're going to have 3 times 2 minus 2 squared minus 2 cubed over 3, subtracting 3 times 1 minus 1 squared, and then you've got minus a third. You can work your way through all of that. You're going to have 6 minus 4 minus 8/3. Then within the bracket you'll have 3 minus 1 minus a third. So altogether, if we tidy all of that up, dealing with your whole numbers here, you're going to have 2 minus 8/3, and then from that bracket you would have your 3 minus 1 is 2, so but we've got a negative outside, so we've got negative 2, but we would also have plus a third. Tidy all of that up and you end up with negative 2 and a third. Now we can't say the area is negative 2 and a third, but what we can say is the area is 2 and is the positive 2 and 1/3 units squared. But remember that what we wanted was the total area, so the total area, right, will be equal to these two things added together. So area 1 plus area 2. If you add all of that together, you get 13 units squared. So a bit more detailed there, because you have to split up the two parts. So if you have a diagram where you've got clearly a bit of the area is below the x-axis, you need to work it out separately. Be aware that you will get a negative value from that area, but for that integral rather, but your area is the positive version, and you need to make sure that you actually make a separate statement there to say the area is positive 2 and 1/3 units squared, and then clearly selecting the total area at the bottom. Now it's your turn to practice.